Hello, everyone. Let me make sure that my laptop is awake. No, it is not. Let me fix that. I was wondering whether that was going to bite me. And if I could get my video, please. Thank you. Excellent. So, welcome back to day 2. I'm Liz from Brooklyn. I'm joined by my illustrator, Emily, and my stenographer, Amanda. Let's play Structured Logorama. So as you all know, our complex systems are really difficult to manage. And as a result, we need to think about what are the right strategies. And I think we all can agree after seeing the talks yesterday that potential cause-based alerts are going to wake you up over and over and over again in the middle of the night. So that's not a great strategy. So instead, as you heard from Alex yesterday, you need SLOs to know when are your services too broken. And you need observability so that you can actually debug and understand what's going on inside of your services. So some of you may think observability, right? That's just another buzzword. You're sick and tired of hearing this from every single speaker. Guess what? I'm here to give you my own definition, right? Observability is not logs, metrics, and traces. Observability is not even the data, regardless of what format it is. Observability is, can you answer questions? And that requires not just the data to work, that also requires you to be able to instrument the data in a manner that makes sense for you and for any product dev teams that you work with. And you have to be able to query the data. You have to be able to actually answer your questions. What sort of questions might you ask? Well, we don't just have break-fix questions. I know most of us have been talking about operational incidents during this Monitorama, but I think we need to zoom out a little bit and look at the broader set of capabilities that observability lets us have, that lets us run better systems, that lets us have happier customers and happier developers. So we need to look at the full life cycle. Can you actually tell whether or not your code is going to work well with your production observability systems when you're developing it? Can you use the same frameworks? Can you actually have visibility into your build pipeline? Do you know that if you check in code right now that it's going to deploy in an hour and a half? Can you actually tell whether users are actually using those wonderful features you and your product devs are building? Those are all super important considerations. This is not just about break fix. You also, as I said, need to have the right kind of data. So let's talk a little bit now about the meat of the talk, which is how do we reduce the cost of storing all of that data? What kind of data? Well, there are several kinds of telemetry data, and I think it's really important that we disambiguate which one is which. So our systems emit a lot of data. Some of it is about user experiences. Those are the kinds of things that Alex Hidalgo told you yesterday about, right? Things like, can a user use your shopping cart experience? We also do have, of course, host metrics. Host metrics can be important, right? Things like, what's the CPU utilization on my Kubernetes pod? However, in reality, most of our problems do not happen on a per host level. Most of our problems in this modern day and age are happening because of interactions between different hosts or interactions of user requests in unanticipated ways with the code that we have written. So this means that we need data about user requests, and it needs to be contextual. It needs to have a full understanding of everything that's happening inside of the request path, as well as everything in the surroundings. Bits of metadata matter, like what's the user ID? Or where's the user located? Or which build IDs was this served from? Or which microservices did it pass through? What was the MySQL query that I ran, right? You need all of this context in order to understand. It doesn't cut it anymore to say, you know what? I know that user traffic in Japan is slow, but I have no further granularity than that. So I'm going to argue to you today that our users' experiences are like beautiful hand-painted marbles. Each one has unique color, shape, pattern, size, weight. They have so many unique properties. And I think that in order to appreciate the experiences of our users, we have to treat them like the valuable and beautiful glass marbles that they are. So I've told you about some of these properties, but I also need to reinforce to you that, again, right, like these are things that our user experiences have, right? Latency. latency, which customer they're from, right? How many of you here operate SaaS services? Software as a service services, right? Right? So my boss, Charity Majors, is fond of saying nines don't matter if users aren't happy. So, right, like, let's suppose that every single end user from one of your top 20 customers is serving 100% down. Do you think that customer's happy? I don't think so, right? Like, we have to care about the fine-grained properties of our users. And when we're doing these kinds of analyses to understand what's happening inside of our systems, we often ask questions that are rooted in how many or how much. That's fundamentally what a lot of the questions that we ask are. Things like, what's the 99th percentile latency, right? That's asking how much latency do I have to have such that 99% of my users experience less latency than that, right? That's a how many or how much question. So, oh, I see. I appear to have tripped the Google Assistant. Okay, so let's use this marble analogy and compare to what we do with our modern systems today. How many of you have ever been to a fairground and seen this game? Count the number of marbles in the jar. How many of you have seen this game? Or count the number of peanuts, or right? Like, pretty common game, right? And it turns out that what we do with our modern systems is a lot like playing count the marbles in the jar. And it turns out there are much more expensive and much cheaper ways of doing it. So we can choose to win the game by counting every single marble, but that would take all day. And the provider might not let you tip out all the marbles and count them. So what if you were asked not just how many marbles are in the jar, but how many yellow marbles in the jar? Or what's the most common color of all of the cat's eye marbles in the jar? Or how many blue marbles are there that are not cat's eyes, right? These are things that you cannot get simply by doing one straight categorization, right? We often have to ask dynamic, complicated queries in order to answer our systems data. So similarly, when we're debugging our systems, we cannot break the bank, right? You cannot have an observability infrastructure that is the same size as your regular production infrastructure. Okay, maybe if you're Honeycomb you can, but that's a different story. So today I'm going to tell you 3 strategies for taming the spew of debugging data. And it may sound a little bit like the recycling lessons that you got in school. Reduce, reuse, and recycle. So let me tell you what I mean by that. First of all, the most important thing that you can do is reduce the amount of data that you're storing. Going back to the marble analogy, what if I asked you to find how many colored marbles there were? Do you really need to count every single clear marble as well, or can you just push them aside and say, you know what, I'm not counting those? Well, it turns out that we also tend to double count our data, right? We tend to, why would we want to cross-check and count the same marble twice just to make sure that we got it right? I don't think that makes very much sense. So to draw an analogy back to the computer domain, we should not write once, read never data. Or at least if we're writing it, we should not index it, right? Sure, your security team needs audit logs. Don't store them in index storage. Put them in S3 somewhere. Put them in Glacier. It's cheap. We also need to think about deduplicating our data storage. You do not need to pay both for logs and for traces. There may be a case for paying for metrics as well, but you should not need separate data stores that are duplicating that data. And this means that we need to structure our logs. And fortunately, I don't have to tell you very much about that because you learned about that yesterday, right? Structure your data, emit wide structured events, emit JSON format, or whatever format logs that make sense for you in order to make sure that you can actually pick apart the data and that you're not writing extraneous, only readable by humans data. We need to not emit multiple different log lines per transaction, right? One user request, one microservice, one wide event, not multiple different log lines that say fatal and info and debug, right? Attach a little structure to it, one event per transaction. And if you have linked events, right, guess what? That is tracing. That is tracing. And that just means that you have events with parent IDs, span IDs, and trace IDs. That's all that is, right? So use tracing for your linked events, and you'll have a much better time of it. And you'll be storing your data efficiently, not duplicating the data, and keeping only the data that you need. Also, as we heard from Netflix yesterday, Consider your attention period. Maybe it's okay to retain the data for 0 days and be able to stream it on demand. Maybe it's okay to stream it or make it available in your storage for 1 or 2 days. Do you really need to pay to keep all that data 3 months? Maybe not. But unfortunately, trimming your data down often is not enough. So let's talk about the next strategy in my list for you. That is sampling. And some of you may say, oh my goodness, Liz, sampling is scary, or I'm afraid I might lose something important. So let's talk about some of the myths of sampling. Statistics can come to our rescue here and help us make sure that we have a good sense of what's going on in our data. And you don't have to, unless you're keeping security audit logs, keep every single record, right? In order to win the marble guessing game, all you have to do is get close enough to the number of marbles, right? You don't need a perfectly exact count to know that there are, for instance, a lot more blue marbles than red marbles. So we need to estimate, and we need representative events for that. So one way of approaching this is to say, you know what? I'm just going to randomly roll a die. If I roll a 1, I'm going to keep it. If I roll 2 through 6, I'm going to discard it. Congratulations, we've gotten down our volume of data by a factor of 6. Lovely. And then afterwards, so that I can reconstruct the data afterwards, right? I can know that when I took this sampled data, each event stands for 6 other events, right? That way my total counts are remaining the same, and I can compare it against the metrics that I'm collecting. For traces, it's a little bit more complicated because you do not want to have broken traces, right? You would either like to pay to keep the entire trace, or you'd like to keep none of the trace. Because having a broken trace means that you're paying for data that you can't really reconstitute and use. So count your traces together, and typically the right way to do this is using the trace ID, or the hash of the trace ID. So this is one mechanism. Because this is a 30-minute slot, I'm going to be brief in going through this, right? If our sample rate, 1 divided by that, is greater than the least bit of the least bits of the trace ID, then we keep the entire trace. Otherwise, we discard it. And the good thing about that is this is a decentralized decision. I don't need to propagate it. We'll get into more sophisticated techniques in a little bit. So do not be afraid of high sample rates. It is okay to have 1 trace or 1 event stand in for 5 events, 10 events, 10,000 events. That is okay, right? I think what matters the most to the fidelity of our data is having a range of different kinds of traces that are representative. I think that that's kind of the better approach to think about. The better approach of thinking is saying, I need at least a certain number of samples per dimension, right? I only need probably 50 or 100 HTTP 200s to understand how my HTTP 200s are behaving, even if there are 100,000 of them. I probably need each and every one of my errors in order to understand what's going on with them. So the number of distinct samples roughly correlates to the amount of accuracy that we get out of our data. So the population size does not actually matter, right? It does not actually matter whether the population of the United States is 300 million people, or the population of my local town is 10,000 people. If I call up 50 people or 100 people on the phone selected at random, or even let's say 200 people on the phone at random, right? I'm going to get a pretty good sense of how those people are going to vote. So if you don't believe me, ask a real data scientist. I just play one on TV. So Joe Ross is from SignalFX, and he gave a talk at last Monitorama Portland about how this is accurate and why. And you'll notice in his figure there that he is retaining relatively few of the things in the bulk of the bell curve, but he's retaining almost 100% of the things towards the tail. So this is going to get crucial in a moment. We have to overweight keeping our extremes in order to make sure that our statistics are accurate for things like inverse quantiles, where an inverse quantile is defined as, instead of thinking about, 99% latency, 99th percentile latency is 300 milliseconds. Instead, you might ask, how many percent of events lie below 300 milliseconds, right? Where it might be 98.9, 99.5, right? So inverse quantiles tend to be safe under dynamic sampling. And service level objectives tend to be safe under dynamic sampling because if you've done them correctly, they're based off of a static threshold rather than based off of a percentile. So, third technique. If you cannot reduce your data, you cannot reuse your data, we're going to have to do some recycling. We're going to have to aggregate some data. So, aggregation destroys your precious cardinality. It's like taking all of these beautiful, beautiful marbles and putting them through a meat grinder. It's not a pretty thing. It's not a thing you want to do casually, but it can be sometimes the only way to cope with an enormous volume of noise. This can have mixed results, right? If I grind up all of my marbles and then sort them by color and weigh the colored fragments, yes, I can easily tell you what proportion of the marbles had yellow coloring. It's really cheap to answer these known queries that I already knew I was going to sort by when I crushed away all of that cardinality. The downside is that it is inflexible for new questions. If I want to ask questions like, what color were all of the cat's eye marbles? Like, how many cat's eye marbles were yellow? I can no longer answer that question because I have destroyed the pattern of the marble when I sorted them by color. Now, we could add a new custom series, but at that point, you are paying a very high cardinality cost because you are paying all of that overhead for setting up another meat grinder to specifically grind up the cat's eye marbles, right? And that's going to cost you in the long term. The other downside is that I can tell that, at roughly the same time that the blue color started turning up more in my ground up marble dust, that I also started receiving an increased mass of marbles. Does that mean that I suddenly had all of the blue marbles become more massive? Or is that just a temporal correlation? I don't know for sure anymore because I've destroyed that relationship. I no longer know how many marbles were larger than a certain size that were also blue. Math on quantiles is misleading, although I do understand there's a talk later today about monoids, which might solve some of these concerns. But in general, you do not want to take the average of P99s. You do not want to take the median of P99s. Just don't do it. It'll give you really inaccurate results. So to me, aggregation is a last resort. Aggregation is something that maybe we do to system statistics, but that we absolutely do not do to user events and user data. So how can we make sampling cheap enough then? How can we make it so that it's cost competitive with aggregation? The way that we need to do this is a couple of strategies. First, let's talk about target rate sampling. With target rate sampling, we're trying to avoid the problem where if our system's load scales, the cost of observing the system is going to scale. We want the predictability of cost either for running our own services or for paying a vendor. We want that cost to remain constant, and we want our retention periods to remain constant. We want to be able to have enough traces to debug, but it turns out that if the volume of queries coming into your service goes up, you don't necessarily have to proportionally keep the exact same proportion. You can choose to adjust your sampling rate based off of the trailing volume. So this might look like refreshing every minute and looking at how many queries did I get in the past minute, and then adjusting your sampling rate for the following minute. It'll lag, but that's fine. And that enables us to keep, over time, a consistent number of events. So that's one way to address cost predictability. And then we can reconcile this using the sample rate, because if we record the sample rate that we had in effect when we took the sample, we'll be able to reconstruct the number of total events. The other thing that I want to introduce you to is the idea of per-key sampling. Not every piece of data is equally valuable, as I was alluding to earlier. 99% or more of your events are low in signal. They're the normal traffic, right? They're the things that meet your expectations, that are below your P99 in latency. Why is it that most systems constrain you to having 99% of your data that's recorded in observability systems be that 99% of uninteresting data? Every customer is absolutely unique, right? So we care about seeing the rare customers, the ones that only give us 1 query per second. We should not let the customers giving us 1,000 queries per second drown them out, because we might care about the health of that one customer that's sending 1 query per second, or we might care about that endpoint that's receiving 1 query per second. So how can we save the relevant events that we need? Well, what we need to do is we need to normalize the data per key. We need to have a different sample rate per distinct key. A different key can have a different probability, and that's okay. So for instance, I might choose to say, you know what? My top 2 customers that are most voluminous, I'm going to sample them 1 for 1,000 or 1 for 10,000, and I'm going to keep everything else 1 for 1 or 1 for 2. I can also choose to retain the erroring queries and the slow queries. However, this requires a bit of trickery, because if I have a trace, I may have to make a decision about whether to keep the rest of the trace downstream before I know what the result of the query is. So we'll talk about that in a little bit. But in short, you can think about creating these buckets, right? Of if it's an outlier in latency or error, then I want to keep it at a high rate. And if it's not an outlier, I want to keep it at a low rate. So we need to buffer, right? We need to use buffering to hold on to traces and be able to do tail-based sampling, where we retain everything that happened during the event, and then we choose to discard or keep the entire trace in a third-party service outside of our immediate event flow. So there are plenty of providers that can do this. It happens that Lightstep, our friends at Lightstep can do this, as can Honeycomb, but I'm not going to belabor that point. So there are a lot of resource trade-offs here, I guess is the main point, is you could build this yourself, but you'd have to think about things like, how much memory do you want to allocate to this? How much is it going to cost you to ingest the data? And how much overhead is there to actually maintain the system of keeping track of these keys dynamically? But it does let you save in the long term on your storage load. So let's put both of these techniques together. Let's put the the target rate sampling together with the per key sampling. So this might look something like this, right? Where we have a key to our hash that is encoding a latency bucket, a customer ID, and so forth, and we're recording how many events happen in each bucket. If we get a key that we don't have yet, we just keep it 1 for 1 until the next interval. But if we do see something that we have a key for from the past minute, then we can know, did I receive 10,000 of these in the last minute? Did I receive 1 of these in the last minute? And then decide to sample accordingly. Our low volume data is super, super precious. You need to keep those diamonds in the rough because those are the things that are going to tell you the most about the behavior of the outliers in your system. And part of our job as people who administer systems is to kind of keep an eye on the outliers and make sure that we understand why they're different from the rest of the traffic and how we can harmonize things to make sure that we stay within our service level objectives. So target rate and per key can achieve really, really great results. And this is actually known as stratified sampling in statistics. But what if you're absolutely dearly in love with aggregated metrics? To that I say, I used to be too. And I actually don't think that these things are too dissimilar. As it turns out, your distributions in your metric system are buckets and counts, right? They're buckets of time with a width of time and a vertical height of the dimension that you're measuring, for instance, latency. And then you have a count of how many events fell into that bucket. So it's almost like we kind of have varying amounts of glass dust spread out across this spectrum, right? It turns out that there's this really cool technique called the exemplar technique. The exemplar technique says, okay, it's fine. You've ground up all this data. It's scattered across all these buckets, but let's keep one example marble that represents the full cardinality of what went into that bucket of sand. And then that way you can tell and you can keep kind of some of that fine-grained data so you can know that most of your 99th percentile latency data happen to be blue cat's eye marbles, even if after you've sanded away all the data, you just know that the glass itself was blue. So exemplars let you marry together distribution and sampled events. And it turns out that these two things are the same concept. It turns out that the amount of stuff in the bucket, that's a sample weight. And the sample value is the sample that you attach to that bucket. I think this is really cool, right? This means to me that metrics and events can be friends. We don't have to fight, we don't have to argue. These two inevitably are leading towards the same place as we wind up having more and more complex systems and troubles that we have to debug. Every metric system is going to have high cardinality exemplar events in the future. Every event system is going to have metrics synthesized from its sampled events. This is fine. This is natural. And I think this is where the future is heading. So I used to work on the Google Stack Driver team, and now I work at Honeycomb, right? And I don't really see a big disconnect in this. I think that I can give you the same message that cardinality matters, and it's about how you produce efficient results out of it. So yes, to wrap things up, every single one of you here, you can prevent data spew. You can stop forest fires, right? Do not write out data that you're not going to use. Think about how are you going to measure your service level objectives, and how are you going to get observability to be able to debug regressions in your service level objective. And make sure that you can do it in a fashion that's cost economical and cheap enough for your business. And yes, your time as a developer actually does matter. Because at the end of the day, part of why we do this is to save ourselves time when doing operations. So does it really make sense to spend, 5 engineer years working on your custom observability solution if it's not going to save your team 5 engineering years of work? Well, depends on the financial costs as well. The one thing that I can say is that instrumentation standards rock. Instrumentation standards are saving everyone a lot of time, because it means that there's not really much of a cost in switching between something that you wrote yourself, something that a vendor provided or another vendor provided, right? Instrumentation tends to be a very expensive one-time cost that you as an engineering team need to pay in order to get good observability. So let's only pay that once. Let's not have to pay it multiple times. So I really am enjoying working on OpenTelemetry. So structure your data. I've been told this plenty of times today. Structure your data, sample it in order to get it cost economical, and if you cannot get it cost economical with sampling, then aggregate it. But please think about using exemplars if you are going to aggregate. And don't feel like you have to do it yourself. So my message to you is refine your data, reduce, reuse, recycle, and do it wisely. My slides are at the QR code, or you can come see me at the Honeycomb booth after this. Thank you so much. I think I have time for one question. I'm seeing 3 minutes on that clock. No question? Oh, one question over there. Shout and I'll repeat it.
What's a good indicator if you pick the right cardinality for your exemplars?
The question is, what's an indicator of whether you've picked the right cardinality for your exemplars? I think the argument is that you should attach an exemplar event with all of its wide fields to that bucket, right? So maybe you have a tracing system, right? In that case, store the trace ID, which is a relatively cheap 64-bit number, right, alongside the latency bucket or the other histogram bucket, right? And then you can just jump straight using that 64-bit trace ID or 128-bit trace ID directly to that trace inside of your tracing system, right? So I think that, yes, it can be sometimes expensive to store, all of the wide fields. So you might want to store a limited subset, but probably the best way of doing that is using a tracing ID in order to connect those two pieces of data together. So that's actually what I used to give talks about when I was at Google. Minute 30, one more question. Over there, sorry. Okay, all right, well, thank you so much. And thank you very much to my stenographer who helped me out with this at the last minute. And enjoy the rest of your Monitorama.